An asteroid wiped out the dinosaurs. Another exploded over Russia and injured over 1,000 people. And the next one could be on its way right now, and no one would know. Here's the truth. Earth is a target, and space is full of projectiles flying at tens of thousands of kilometers per hour. Rocks the size of stadiums, skyscrapers, mountains. In 2023, an asteroid passed just 3,000 kilometers from Earth. That's lower than many satellites, and it was detected only 2 days before. 2 days. If it had hit, there would be no evacuation, no warning, just impact. And where a city once stood, there'd be a crater. NASA knows this, and they're racing against time to track the biggest threats. But not all asteroids can be seen. Some come from angles where the sun blinds our telescopes, and those are the worst. In this video, we'll show you what asteroids really are, where they're hiding, and why the next one it might not ask for permission. Have you ever stopped to think about what asteroids are really made of? They're not just rocks floating in space. The composition of an asteroid can vary immensely, and understanding this can reveal many secrets about the formation of our solar system. Asteroids can be composed of a wide variety of materials. Some of the most common are rocky asteroids, made primarily of carbon, silicate, and carbonate. These asteroids, known as C-type, are the most abundant in the solar system, and their darker color makes them harder to detect. They may even contain water and organic compounds, which strengthens the theory of panspermia, suggesting that asteroids could have been responsible for delivering the building blocks for life on Earth. On the other hand, there are metallic asteroids, classified as M-type. These are primarily composed of iron and nickel, making them much denser and brighter. These asteroids are considered remnants of primitive planets that never formed due to the gravitational influence of other bodies in the solar system. Due to their metallic composition, these asteroids are especially interesting to scientists because they can provide insights into the early stages of planetary formation. Another type of asteroid, known as S-type, is a mixture of rocks and metals. These asteroids have a brighter color, making them easier to observe, and are composed of silicates and metallic materials, placing them somewhere in between C and M types. Finally, there's a less common class of asteroids, the water-rich ones, known as P-type. These asteroids are particularly interesting because they contain large amounts of water, a crucial resource for future space missions. Additionally, these asteroids may house chemical compounds that help explain the origins of life. What's truly fascinating is what these asteroids tell us about the early solar system. They are remnants from a time when the solar system was still forming, and their compositional diversity can provide valuable clues about the conditions that existed at that time and the processes that led to the formation of planets. Asteroids don't just appear out of nowhere. Every rock, every space object that threatens Earth, has a place it calls home. One of the main sources is something called the asteroid belt. It's a massive ring of rock and debris orbiting the Sun between Mars and Jupiter, millions of chunks of ancient matter, leftovers from the creation of the solar system. They've been floating there for billions of years in a chaotic dance. And most of them, they're harmless, locked into stable orbits, far from us. But sometimes the stability breaks. A gravitational nudge from Jupiter, a collision between two rocks, a distant comet passing by. That's all it takes for one of those objects to be kicked out of its orbit and sent flying toward the inner solar system, toward us. These are the rogue asteroids, the ones that escape the safe zones. And once they're out, they don't follow traffic rules. There's a category of them called NEOs, near-Earth objects. These are the most closely watched asteroids because their orbits intersect with Earth's orbit. Some pass just a few thousand kilometers above us. That's closer than most satellites. But here's the terrifying part. Not all asteroids take a straight path, and not all of them come from open space where telescopes can spot them. Some come from the direction of the Sun. When that happens, our detection systems go blind. The sunlight overwhelms our sensors. The sky looks empty, but it's not. A massive asteroid could be heading straight for us, completely invisible until the final moments. That's exactly what happened in 2013. A 20-meter-wide asteroid entered Earth's atmosphere over Chelyabinsk, Russia. It exploded with the force of over 30 Hiroshima bombs. More than 2,500 people were injured. And it wasn't seen until it was already inside our atmosphere. That's not an exception. That's reality. But it doesn't stop there. Far beyond the asteroid belt, beyond Pluto, there's a region that few people even know exists. The Oort cloud. It's a vast frozen sphere that surrounds the solar system. A kind of cosmic graveyard filled with icy debris, comets, and ancient objects. We estimate it contains trillions of bodies, and any one of them, if disturbed, could be flung inward at high speed. From that distance, a comet would give us only months, maybe weeks, before impact. So here's the big problem. Space is enormous. The darkness is endless. And even with all our technology, we're still mostly flying blind. In 2022, astronomers discovered a massive asteroid, 1.5 kilometers across, big enough to cause global devastation, and it passed right by Earth, without being seen until after it had already gone. Imagine that. A skyscraper-sized rock flying through space, close enough to ruin continents, and we missed it. That's not a rare event. It's a wake-up call. We're scanning the sky every night. But there are still countless objects we haven't found. Some are too dark, some too small. Some come from blind spots we can't monitor. So when we talk about asteroid threats, we're not talking about science fiction. We're talking about things we've already seen, things we missed and only noticed after they passed. The only question is, what happens when we miss one that doesn't pass? Let's say it happens, not in a movie, not in a simulation. Right now, a massive asteroid, the size of a football stadium, is heading straight for Earth. No deflection, no escape. The first thing you'd notice is nothing. The asteroid would be moving at over 20 kilometers per second. That's faster than a bullet. And it would be almost silent until the final seconds. Then suddenly, the sky lights up, a flash brighter than the sun, and 1 second later, impact. Let's break it down. An asteroid just 150 meters wide, not even one of the big ones, could release more energy than 30 nuclear bombs the moment it hits. If it struck land, it would vaporize everything in a radius of several kilometers. The shockwave would flatten buildings tens of kilometers away. People would be thrown by the blast. Glass would shatter hundreds of kilometers around. If it hit the ocean, that's a different nightmare. The impact would trigger mega tsunamis, walls of water 100 meters high, racing toward coastlines at jet speed. Entire cities near the shore would disappear in minutes. But here's the real horror: the dust. A large enough asteroid would throw millions of tons of debris into the atmosphere. This would block sunlight for months, maybe even years. Prime would fail. Temperatures would drop globally. We'd be facing a nuclear winter. Without the nukes, in the worst-case scenario, the Earth's climate could collapse. And we're not talking about extinction of just humans. This is the kind of impact that erased 75% of life the last time it happened. Remember the dinosaurs? They didn't die because of the rock itself. They died because the world changed overnight. No food, no sun, fires, acid rain, a planet in chaos. And the asteroid that caused that extinction was about 10 kilometers wide. We've already discovered hundreds of similar-sized rocks. Some of them are still out there, and a few are on very suspicious orbits. If one of those objects was ever confirmed to be on a collision course, we might only have months to prepare. And currently, we have no guaranteed way to stop it. NASA is testing deflection missions, but none of them are ready for a real emergency. We don't have a global response plan. No bunker deep enough, no shield strong enough, just a fragile planet, spinning in a shooting gallery. So the next time someone says just a space rock, remember, one of them already ended an entire era of life, and space hasn't stopped throwing rocks. You might think asteroid impacts are rare, but what if I told you? We've already come dangerously close, and most of the world didn't even notice. Let's go back to October 2021. An asteroid the size of a skyscraper, over 400 feet wide, passed by Earth at a distance of just 300,000 kilometers. That's closer than the moon. And here's the terrifying part. We discovered it only one day before it flew past. No warning, no headlines. Just a massive rock silently slipping through the gap. But that wasn't the first time. In 2004, astronomers spotted an asteroid called Apophis. It's over 300 meters wide, enough to cause continental devastation. Early calculations showed a 1 in 37 chance it would strike Earth in 2029. That number may seem small, until you realize those odds are insane by cosmic standards. For months, Apophis was the most watched object in the solar system. Scientists ran simulations. The world held its breath. Eventually, we ruled out a 2029 impact. Barely, but Apophis will still pass so close to Earth. It will fly beneath some satellites. Yeah, you heard that right. This thing will pass inside the ring of our orbital tech. One tiny miscalculation, and it becomes an extinction-level event, and it gets worse. In 2023, a small asteroid, only about the size of a delivery truck, entered Earth's atmosphere over France. It was harmless. But here's the twist. It was detected just hours before it arrived. That's the best-case scenario. Small rock. Remote location. No damage. But what if it had been bigger? Or over a city? Think about that. We live on a planet where massive objects fly past every week, and we only catch some of them, sometimes after they've already passed. One day, this won't be a close call. It'll be a direct hit, and we might only know hours or minutes before it happens. So no, the danger isn't in the movies. It's in our blind spots. In 2019, a 100-meter-wide asteroid passed by at a distance half that of the Moon. We didn't see it coming. Not because we weren't looking, but because it came from the solar glare. The side of the sky our telescopes can't observe during the day. These aren't what-ifs. These are documented close calls. The truth? Earth has been lucky. Very lucky, but luck has an expiration date. The question isn't if we'll get hit again, it's when. All right, you've seen the danger. You've felt the tension. But here's the real question. Can we stop it? Can humanity actually defend Earth from an asteroid? The answer? Maybe, but we're not ready yet. First, forget the movies. Nuking. An asteroid is not our first option. In space, a nuclear blast might just break the rock into multiple deadly fragments, all still heading toward Earth. Instead, scientists are betting on something much smarter. Deflection. In 2022, NASA launched the DART mission, the very first real-world test of asteroid defense. The goal? Slam a spacecraft into a small asteroid moonlet called Dimorphos and see if we could change its orbit. No explosives, just kinetic energy, like a space battering ram. And it worked. For the first time in history, humanity altered the path of a celestial body. That was a huge win. But here's the problem. Dimorphos was a test target, small, isolated, and harmless. The next threat we face won't be a training dummy. What if it's 500 meters wide, or coming at us in just 6 months? Suddenly things get complicated. Right now we have a few ideas on the table. Gravity tractors. A spacecraft could fly next to an asteroid for years, using gentle gravitational pull to slowly shift its orbit. Laser ablation. High-powered lasers could vaporize material from the surface, creating a reactive push. Mass drivers. Machines that eject small amounts of surface rock to change trajectory. Sounds futuristic? It is. None of these are mission-ready. Most exist only in blueprints or simulations, and time is not on our side. As of now, we've discovered about 32,000 near-Earth asteroids, but experts estimate there could be hundreds of thousands we haven't seen, especially smaller ones under 140 meters. And some of them, as we've seen, only show up when it's too late. We need faster detection, better coordination, and most importantly, a real global action plan. Because if an asteroid is confirmed to be on a collision course with Earth, and we only have months, it won't be science fiction. It'll be a race against extinction. And here's the truth. Space doesn't care about borders, or politics, or waiting for funding. If we want to survive the next big one. On June 30th, 1908, the sky over Siberia cracked open. It was morning. The sun was already shining, when an even brighter light tore across the sky. Seconds later, an explosion, as powerful as 1,000 atomic bombs, shook the land. But there, was no crater. The event became known as the Tunguska explosion. A chunk of space rock about 50 meters wide entered Earth's atmosphere at over 50,000 km/h. The pressure and heat caused it to explode roughly 8 kilometers above the ground. The blast knocked down more than 80 million trees. A whole forest, flattened as if something massive had steamrolled it. If it had hit just a few hours later, it would have struck the cities of Europe. And instead of trees, we'd be talking about millions of lives lost. But it didn't. It hit Siberia. And that's the only reason no one died. But here's the thing. No one even knew what had happened. The first expedition to the impact site only happened 19 years later. When scientists arrived, they found a strange, butterfly-shaped blast zone. Burned trees, all laid flat in the same direction, like the wind from hell had swept through. No crater, no asteroid fragments, just silence and fear. Tunguska showed us what a single 50-meter asteroid can do. Now imagine one 500 meters wide, or 5 kilometers. What happened in Siberia was just a warning, a test, and it wasn't the last. In 2013, a 20-meter asteroid exploded over the Russian city of Chelyabinsk. The shockwave shattered windows in thousands of buildings. Over 500 people were injured, and no one saw it coming. It came from the direction of the sun, invisible to our telescopes. 2 events, 2 warnings, both in Russia, both with 0 warning. What if the next one doesn't explode in the air but slams into the ground? Tunguska was just the beginning. Because here's the truth. Earth is on a collision course with space. After the Tunguska event, humanity finally woke up to the real risk of asteroids. But the question is, what are we doing to protect ourselves? Are we ready to prevent the next impact? Or will we wait until it's too late? The first line of defense starts with sky observation. Today, we have powerful telescopes and dedicated space missions monitoring space rocks that might threaten Earth. NASA's Near-Earth Object Program, NEO, aims to identify and catalog asteroids passing near our planet. But even with all this, there are thousands of objects we still can't see. And the worst part, most of them are traveling in the direction of the sun, making detection even harder. In 2020, NASA launched the DART mission, Double Asteroid Redirection Test. The goal? Test a new planetary defense technique. What did they do? They crashed a 600-kilo spacecraft into the Didymos B asteroid to see if they could redirect its path. Impressive, right? And it was a success. The collision changed the asteroid's trajectory by 0.4 millimeters per second. That may seem like a small amount, but in the long run, it could make all the difference. If an asteroid were headed for Earth in 10 or 20 years, that tiny shift could be enough to prevent the impact. But what if that doesn't work? What then? The truth is, we're far from having a 100% effective defense system. The biggest problem is the reaction time. If an asteroid is approaching rapidly and we don't have enough time for a deflection mission, our options are limited. Some theories suggest the use of nuclear bombs to destroy or redirect an asteroid. Others, like the use of lasers, imagine that we could use cutting-edge technology to burn an asteroid and break it apart, but this solution is still just theoretical. One of the biggest challenges we face is funding and international collaboration. Even though we know the risk, most countries still don't heavily invest in planetary defense programs. So far, the only international treaty that touches on the subject is the Outer Space Treaty, which prohibits the use of nuclear weapons in space, but doesn't mention how to defend against natural threats like asteroids. So, what can we do as individuals? The sad answer is, not much. We have to wait for governments and space agencies like NASA and ESA to develop defense technologies. The good news is that they're starting to take it seriously, and while it may sound like science fiction, asteroid deflection has already been tested, and in the future, it could become a reality. The risk is real, but at least we are starting to do something to prevent another Tunguska or Chelyabinsk-like event. Now that you know more about asteroids and their composition, like the video, subscribe to the channel, and turn on notifications so you don't miss more amazing content. Leave a comment below letting us know what you think, and share it with your friends. See you in the next video.